Hello and good afternoon to everyone. So I've been asked by my friend, how can we solve this kind of question? So this question I take from our first physics test, question 3B. So in this question they ask us, how can we determine the current flowing in I1, I2 and I3? So they already give us the direction where the current is flowing for I1, I2 and I3, and then the loop that we need to use, where direction we are moving for our point of reference. And there are two things that we need to know in order for us to tackle this sort of question. The first thing we need to know is we need to understand the Kirchhoff law, the Kirchhoff voltage law and the Kirchhoff current law. And the second things that we need to have is we need to have the mathematical skill in order for us to solve the expression that we have made based on the Kirchhoff law that we have made previously. So without further ado, let's begin our discussion. So the first thing that we need to see is we need to see where the direction of the current is flowing. So this question already gave us the direction of the current flowing. So I1 in this section, all this section are I1. So current is moving in this direction. For I3, the current is moving into this direction. And for I2, the current is moving into this direction. And then the next thing that we need to do is we need to put a sign in front of the component. So we except for the battery, so because battery we agree to put that positive as at the long terminal and the short for negative. So for the battery, for the resistor, it depends where the current is flowing. So if you assign the current flowing into this direction, so when the current is flowing into this direction, this terminal must be positive and this terminal must be negative. Since this current is flowing into this direction, so this part must be positive, this part must be negative, this part negative, this part is negative because it's moving into this direction, decreasing in a way that is decreasing the potential difference. So this is positive, high potential difference to a decreasing potential difference. Okay. Next is we need to form the expression based on the Kirchhoff rules. So the first thing that we need to look is at this junction B. We know that based on the Kirchhoff current law, current entering a node or a junction must equal to the current exiting the junction. Meaning here that I1 plus I2 is equal to I3. So this is our first expression. And then we need to use the Kirchhoff voltage law for us to determine the potential difference inside this loop. So it says that all the potential difference, the summation of potential difference inside a loop must equal to 0. So based on our first loop, let's say we start at point F. So we first meet the positive sign of this resistor. So the potential difference across this resistor correspond to positive 10 multiply with the current flowing across the resistor. The resistance multiply with the current. So let me first explain. Potential difference across resistor 2 is equal to current flowing in this resistor and the value of this resistor R2. So this is for the value of the potential difference across R2. So we need to put, since we know it's 10 ohm, so we need to put 10 multiply with I1. As we go through the wire, we meet a negative terminal of the battery, so we put negative 20 volt. We move and then we meet positive terminal of this resistor. So 5I1. Here we meet the positive terminal of the battery, so we put 20 volts positive. Here we meet the negative terminal of this resistor, so it is negative R4, which is 3. And then here the current flowing in this section is I2, so we need to put I2 here. Moving again, we mean R1, so R1 is the potential difference here is positive 12 I1, and then we meet at the point where we started, so we conclude that this expression must be equal to 0 based on the Kirchhoff voltage law. So we need to simplify this expression.